All right, so this is our first lecture on periodic motion. And I'm just going to give a brief intro to try to motivate why we're going to talk about periodic motion. So in your first physics course, you studied mechanics, the physics of macro scale things and how they move. Talked about forces and energy. And in general, you learned how to describe the motion of these bodies. And you probably started with the basics, linear motion and constant acceleration, and then you learned how to deal with changing acceleration and forces applied in various dimensions. And then you covered rotational motion, which kind of just twisted everything into this different spinny version of all the same things. So the variables changed, the notation, the nomenclature changed, but hopefully you were able to see that a lot of the equations were kind of easily relatable to their linear counterparts. And if you got far enough in your first physics class, you may even have covered more complex systems like rockets and fluids. So you might beg the question, what's left? What kind of motion could there possibly be? I mean, you got as far as rockets and water and how things spin. Well, there's a lot left. And one of the biggest ones that has been omitted thus far is this periodic motion. So this is actually found across all kinds of fields in physics. It's the physics of how things oscillate or vibrate. And it turns out everything oscillates. Everything is vibrating. If you look on some scale of matter, everything is vibrating. And the dynamics of how many systems operate lend itself nicely to the mathematics of describing oscillating things, periodic motion, vibrating things. So let me give some examples, and let me explicitly say that we're going to use a lot of terms interchangeably that have some subtle nuanced differences, but we're going to use periodic motion, oscillation, and maybe even vibration sometimes interchangeably. They just refer to things moving back and forth, right? So the classic example would be a pendulum that moves back and forth. So typically you'd have some surface that a pendulum is attached to, and you have some tension, either a string or a stick or something, and then some mass, whether it be a point mass or a full body, and it takes this curved path like that, and it's swinging back and forth. So this back and forth motion is periodic motion. It's motion that is periodic. You can assign a displacement or a placement on some axes, whether it be linear or curved, and count it per time. Another example is the tiny vibrations of a quartz crystal to keep time in a modern watch or computer. So that's, if you've ever wondered how things keep time, how everything can sync up, it's based on the vibrations of a quartz crystal. And there's an oscillating quartz crystal inside of every single device you've ever used. That's how it keeps time. The periodic compressions and expansions of air as a sound wave travels to you from, say, a speaker. So these are compressions that, how can I describe this? Compressions that are periodic, like this, that we will talk about. So if these lines demonstrate how close or far the air molecules are as sound travels through them, this is the type of wave that you would see as it travels from some speaker to whatever's receiving it, a microphone. And finally, similar, I guess, to the quartz crystal example, but just to explicitly point out, the thermal vibrations of every single atom you have ever interacted with, everything has some temperature. There's no 0 Kelvin, so that's a temperature scale. So there is no 0 degree thermal energy. And so everything is moving in some way, even the things that are completely still. If you zoom way in, even if you have to get to the atomic scale, everything is in motion, and they're thermal vibrations. So the universe very much speaks in the mathematics of vibrations and oscillations. They're everywhere. Everything is oscillating. So therefore, understanding periodic motion and learning how to describe it will help you speak that language of the universe just a little bit better. All right, hopefully that motivated the topic well enough.